Hi, my name's Joey. I'm going to be presenting my topic flip/pick fluids, which is a hybrid approach to fluids. So it uses both Eulerian and Lagrangian properties. First, we have a bunch of particles, which we transfer velocity to the grid. Then we solve the incompressibility on the grid, and then transfer the velocity back to the particles with bilinear interpolation, and then integrate the particles using an ODE solver. Next, we have flip fluids, where we start out the same thing. We transfer the velocities to the grid, but we make a copy. Then we solve for incompressibility again. And then our next step, we compute the difference between the original copy and after solving it for incompressibility, and then transfer to the velocity to the particles and integrate the particles. Here we have the actual demo, which we can see a water droplet at the top falling onto a basin of particles below. Take special note of the pick/flip ratio, which indicates the percentage of pick velocities versus flip velocities that is eventually transferred to the particles. Here we have a relatively low pick/flip ratio, which means that a greater portion of the velocity is calculated from the flip method. Next, we see the results of having a higher pick ratio, which makes the fluid more viscous, resulting in more dampening and less random motion. Now we have the pure flip method. You can see that within the particles there's a lot more motion, and they act individually as opposed to being clumped together. Lastly, we have the pure pick method, which looks a lot more viscous and lacks the natural graininess and randomness of actual water, but very well emulates surface tension. And this is caused because of numerical dissipation, and it suffers from drift as well.